Okay, so good morning to all of you. Uh, I'll just show you some of the research that you okay. Okay. So we are doing at IIT Patna in the different areas of AI, NLP, and machine learning. So I hope you know the acronyms AI, NLP, what stands for, and ML is machine learning, NLP, natural language processing, AI, obviously the artificial intelligence. And we also have a research group at IIT Patna named after this. Okay, so I'll just tell you where we are focusing on. Particularly, uh, I don't have time to talk to you about different things, about different research things, but I will just give an overview that what we are actually doing, particularly where I am involved, the kind of activities. Madam is also working related to these domains, but probably you have heard from her, right? So this is what AI is. So this, I think I have told you at the beginning, so that these machine learning and NLP, so these two things are very interlinked to each other. Okay, so they are very cohesive. Okay, so you cannot just these days particularly you cannot build NLP systems without doing machine learning. Or if you look at the machine learning theories, for example, the machine learning theories are mostly validated by computer vision's problem, natural language processing problem. So both needs each other. So there are machine learning needs natural language processing, and NLP also needs machine learning. So there is a strong linkage between these two different disciplines. Okay. Now, why NLP will talk? So NLP follows this kind of layers. Okay, so and this we call as a NLP trinity, because these are three-dimensional representations. You can see that in one dimension you have different languages. In one dimension you have different problems of natural language processing, starting from morphological analysis, part of speech tagging, parsing, semantics. Then there will be discourse, co-reference, etc. Discourse, pragmatics. And on the other axis, you have different algorithms, like, for example, hidden Markov model, maximum entropy Markov model, conditional random field. These days, mostly are deep neural network based, particularly RNN and its different variations that you have been observing. So, what does it mean? It means that NLP you can represent as a triplet where one component represents a problem, one component represents a language, and the other component represents a way to solve those problems. Okay, so if I say that, okay, develop a part of speech tagging that tags each and every token of a sentence or word of a sentence by a specific grammatical category, then the problem is known as the part of speech tagging. So now if you are doing it for English, you have different kind of morphological structures. Morphological structure means how the word is constructed. Okay, so that is what the morphology, the structure of the words. Then it follows a different kinds of inflections. We call them as a kind of suffixes, prefixes, infixes that are attached to the to a particular word. If you say it is cats, 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 so the origin word is cat, cat, right? You have added is to make it plural. So you see that origin of the word. So that gives you a kind of structures. So if you are doing the part of speech tagging, let's say for Hindi, and if you are doing part of speech tagging for English, they may not be the similar things because the language is different. So their structures will be different. Their properties will be different. So depending upon that, this side, your algorithm may also differ. Maybe, let's say, CRF kind of thing, conditional random field may work well for Hindi, but maybe not for English. It may happen like this. Okay, so there is a kind of combination of these three, and this actually tells you that how the information flows in a pipeline of NLP. Like if you know the compiler or you have studied the compiler also follows these steps. So you have the very lowest level, the lexical analysis, then you have the syntax, then you have the intermediate code generations, right? You have after syntax, you have syntax directed translation. We call them as a kind of semantic analysis is in compiler. Then you have intermediate code generation. Then you have code optimizations, and finally the code generation. So these steps you follow. NLP also follows quite similar kind of steps. So at the very lower level, you have to tokenize, like in compiler you do. So if you give a programming language statements, So the very first step is to lexicalize it, tokenize it. That you have to understand, if you write that while x is less than something 10, then do something. So now while is a keyword that you have to understand first. Okay. Now x is a variable that you have to understand. Less than is an operator that you have to understand. So these are all stored in a symbol table in a compiler. So in NLP also now, the programming language you are not using, you are using a kind of a natural language. So natural language sentences we are writing, and these sentences is comprising of set of words. Okay. You see that at first, very first step is the morphology, mean lexical analysis. Then part of speech tagging you have to do, that you have to assign a grammatical category to each and every word of the sentence. Then you have to group them together. So let's say noun phrase, verb phrase, adjective phrase. Noun phrase is what? Article followed by noun. If you say the sun is a noun phrase. So the is an article and sun is a noun. So article followed by noun. So you have to group more than one words together. And then you have to combine these individual chunks to form a meaningful sentence. After chunking, you have parsing. Parsing does what? Parsing completely parse the input sentences, okay, and then create a kind of then they create a kind of tree-like structures, that what kind of syntax it follows, what kind of grammar is followed. So that structures you have to give now to the sentence. Okay, that is what is the parsing does. NLP also does the parsing, because once you have understood that different tokens, different words, then what kind of grammar is it follows, that actually you have to decide. And that grammar, following that grammar, you can form a kind of tree-like structures, which is the parsing in case of NLP. Then you have semantics. Now you have to assign a meaning to that word. If you say it is a bank, so bank is a word. So the bank can have multiple meanings. So bank can be the place from where you can withdraw some money. Bank can be the river bank, right? So if you say that, okay, a person was walking by the bank of the river, so here the bank is not the place from where you can withdraw money. So rather this bank is a place where you can walk, or maybe related to the river. How do you know that? So that is a good question actually. Okay, then if you say that, okay, I wanted some money, so I decided to go to the bank. Now in this case, the bank is the place from where you can withdraw the money. So depending upon the context where a word is placed, so its meaning can vary. Okay, its meaning is not universal, or so that means not the semantics. Dealing with the semantics, the meaning is a very complex process, and same word can have multiple meanings depending upon where it is used. Okay, interest, for example, is another example. If you say that, okay, I have strong interest in deep learning, so now in this case interest is a different. But if you say that, okay, I am paying a lot of interest for my credit card, now these two interest word have two different meanings. How do you know that? So these are all the semantics, and we do it word level meaning. Then at first, once you know the word level meaning, then you have to combine them together. So those are the compositional semantics we call sentence level meaning. And after you know the sentence meanings, then you have to know the document level meaning. So these are the different layers of even in the semantics. Now, once you assign the semantics is related to, in compiler, is a kind of syntax directed translation. There is a step. So where every programming language, variables, etc., you have to assign some values to it. So let's say if you say that x and y, you are adding two numbers. If you give that x is 4, y is 3, now this value assignment is syntax directed translation. So this is equivalent to semantic analysis in case of natural language processing. Okay. Then you have the discourse and co-reference, then pragmatics, etc. Those are all the higher level tasks. So it needs everything. It needs semantics, it needs parsing, it needs lexical analysis, everything altogether. So for example, you are doing sentiment analysis, you are doing summarizations, you are doing machine translation, one language to other language, you are creating a chatbot. So all these will require the understanding of all the lower level processing. That means if your semantics is weak, it is not perfect, then you cannot build a good sentiment analysis system, or let's say summarization system. If your parsing is not good, then this kind of errors will propagate in the upper layer. Let's say you are doing this codes, let's say you are building a co-reference resolution systems, okay, or let's say here you are doing a summarization system, or let's say translation. Now, if the semantics is weak, is not very perfect, these errors will impact the upper layers. So the AR propagations will happen, you see, that in these particular directions. And as you go up, the complexity of processing will increase. But also it is the case that the information flow is not always unidirectional. It is not the case that always the information flows from parsing to semantics or chunking to parsing. The information may flow from the upper layer to the lower layer also. So for example, sometimes for parsing ambiguities, that which parse tree will be generated, you may need the knowledge of semantics. It is not the case the semantics always need the parsing, but the other way also is possible. Parsing may need semantics, because in NLP the most hardest thing is that ambiguity handling. Okay, so that makes the task more complex. Formal language, programming language is also ambiguous. So given a programming language statements, you can draw a multiple parse tree. So that is the notion of ambiguity, right? Because for a given string, you have multiple ways to derive it. NLP sentences are also like this. Given an input sentence, you can derive it in multiple different ways. Now, the amount of ambiguity, the number of different parse tree that is possible for a NLP sentence is much higher than a programming language sentence. So that is what is the difference. That ambiguity in NLP will be at every layer. So starting from speech processing, phonetics, when you speak, there are a lot of ambiguities. So depending upon how you are actually when you are taking a pause, when you are speaking, taking a pause, and then you are started to speak. So this kind of disfluency we call, that will also introduce a lot of ambiguities. Then parsing, there are a lot of ambiguities. Semantics is obviously there are a lot of ambiguities. Ambiguities means what? One word, one structures, one sentence can have multiple meanings in this case. Okay, and this ambiguity handling is the most difficult part in NLP. And sometimes for ambiguity resolutions at a lower layer may require some upper level informations. So this information flow sometimes can happen in both the directions. That is the why in deep neural network. So one of the reasons may be possibly that the information, if you are adding lot of layers in between the output layer and the input layer, so you can assume that all these processes, because NLP also happens in layers. So you can say that okay, first layer of deep learning probably solving the task of lexical analysis. Maybe the more layers, deeper the layer, maybe they are solving some deeper level, parsing kind of structures they are capturing, syntax level information. Then another layer, maybe upper layers, maybe doing some kind of semantics analysis. So deeper the layer is, okay, so maybe you can say the different level of abstractions of the NLP sentences it can capture. Okay, that probably one of the reason why, if the neural network is very deep, so you can probably capture different phenomena of languages, and you can solve the problem in an efficient manner. Okay. Now, India, you know that it is a multilingual country. There are a lot of languages in India, and many of the languages are in the top spoken languages. And this is what the statistics of, there are 122 languages in India. There are 1600 regional languages, 13 scripts, 720 dialects, 30 languages are spoken by more than 1 million native speakers, and 122 are spoken by more than 10,000 people. Only 20% knows English, 80% cannot. Now, how to enable this 80% of the society so that they are digitally literate? How can you make sure that a farmer in a village can understand that the prices of any commodities, agricultural products, the market conditions, that in which market they should sell their let's say products, or from where they should buy. Okay, so what kind of government schemes are actually launched for the farmers? So how a farmer will understand all these things? If you are in healthcare, for example, in a rural area, the how a person who does not understand many medical terminologies, how they will be given the information what their health record says, that medical report, you have undergone some kind of test, I want to know that in my own language, in my own layman term, that what has happened to me. Okay. So then let's say that some government notification is coming. There are a lot of government schemes these days, right? So the common people would like to know about those. Okay. So how can you enable them that they understand this? This is only possible by enabling them by to communicate in their own language. Okay, that is one of the very important problems. Okay, so that means you have to build the systems that can work with multiple languages. Like Google search, if you see, Google Translate, if you see, why they are so popular? Because Google search, you can give any query, whatever you don't know, you give a query and you try to get an answer to that. Okay, it becomes a kind of question answering system these days. So whatever you don't know, you ask to Google, Google will give you some kind of answers. Nowadays, Chat GPT also you are using, probably they can also do a lot of things. Okay, so then Google search, if you see that they can also search these days in different languages, right? Search keywords can be in different languages. Translation, Google Translate, if you don't know, you are traveling to Europe, some of the countries, or let's say Japan, for example, Korea, for example, China, for example. So now many of the shopkeepers or many of the signages, etc., travel sites, all are in their own languages. How do you understand that which restaurant to go for eating, taking foods, which hotel to book, which particular destinations to travel? So you need that those informations to be available in your own the language that you understand very well. Okay, so these are all the fundamental requirement because this is the necessity of the society, and until and unless you make these all the informations available in the languages that people understand very easily, you cannot say that digital India movement. So digital India is a movement of our government that tries to enable all the people to be technologically enabled so that they understand they get all kinds of information in the languages that they understand. So that means what, you have to build the NLP systems, okay, and powered by let's say machine learning, deep learning, etc. Even the hybrid kind of system where rules will come into the pictures, and then that should practically work in reality, because AI, machine learning, NLP is not only theory. Okay, so you see that Google search is popular because it actually works in reality, but there are a lot of theories behind it. It has not happened in one day. Continuously they are doing it. Google Translation, why they are so popular? Because they have been continuously upgrading it. So a lot of theories are behind it. But why it is popular? Because they are working on the ground. So in any NLP systems, if has to work on the ground, then only the people will be benefited. Okay, that aspect you should keep in your mind, that it is not only the theory. That is why in NLP research, the availability of the resources, codes that you have implemented, all these have become these days very important. Okay. Also, these days you see that there are social media also, people are communicating in their own languages, and as I mentioned that this digital divide you cannot tackle until you have a freedom to communicate in your own language. Okay, this is very important. So now AI and NLP has progressed a lot. These three disciplines, they are very interlinked, because you understand that NLP ML is a part of AI. AI is the whole the bigger overview, and within that there are different aspects. So NLP and ML is one of the aspect among them, and these are all the very good examples that the powerful tools or the systems that have been developed over the period of years with the help of NLP and machine learning. And these days you also know this Chat GPT, GPT-4. And now if you see the machine learning also, this has been earlier people were using a kind of classical feature based machine learning. You have to define the features by yourself. But these days deep learning does not require those feature engineering. You can, if you have a lot of data, if you have a good mechanism for representing the data, then probably you can build a good systems. Okay. So feature engineering is not needed, because feature engineering is actually time consuming and a lot of handcrafting of features is needed. Now, deep learning, you see that we don't need this feature engineering. So that is what these days only this distributed representation of the word is important, because the distributed representation is coming from distributional semantics in NLP. So semantics means the meaning of the word. So what is the distributional semantic? The very old proverb that a person is known by the friend he or she keeps. Probably you know, right? So I know you. Probably I am not connected to you, but I am connected to him, and I know that you both are very close friends. Then I'll get an idea about you, even I don't know you personally, because I know that who are the persons with whom you are very good friend. Okay, and I know one among them. So if I know one among them, then I'll get an idea about the others also. So this philosophy is the distributional semantics. So a person is known by the company he or she, or the friend he or she keeps. So now a word is also like this. A word is surrounded by the other words. Okay. So for example, if I say that okay, king and queen. Now, these are the two words. Why they are very close to each other? Because if you look at the context, the kind of sentences where the word king is appearing, and the different sentences where the queen is appearing, you will see that their surrounding words will have lot of overlaps. Why? Because king and queen had close, and then you get an idea that king and queen might be related very close to each other. Why? Because the situations where the word king is used, they have a lot of similarity with the situations where the word queen is also used. If you say it is New Delhi and Paris, for example. Now, New Delhi and Paris, why they can be closely related? If you read a lot of documents, you will see that the term Paris is the capital city of France. New Delhi is the capital city of India. So whenever there are a lot of write-up on India or a lot of writings about France, you see that the kind of words means I'm saying the words that surrounds the term Paris. That means previous words, the following words, where the Paris is appearing, the previous few words, following succeeding few words, where the term New Delhi is appearing. So if you see this, then those surrounding words will have closer proximity. And this is happening because semantically, New Delhi and Paris will have some kind of similarity because both of them are the capital cities of two countries. Okay. So that means what? Here also, the word Delhi is known by the other words where it is appearing, and the Paris is also appearing in the context, and those contexts are similar. That means contexts are similar means what? You know the friends now. I don't know what about Paris, I don't know about New Delhi, but I know the other words where these two words are appearing. And I know that those two words are very similar. So that means you know their friends. You are knowing their friends. So if you know the friends, then even if you don't know each other, then probably you also know some kind of that, okay, maybe we have some kind of commonality. That is how the Facebook, LinkedIn, all the kind of connection happens, right? So if you are connected to the Facebook, so unnecessarily you don't connect. There are a lot of profile matching, common understanding, then you get connected to those kind of network, right? So that means what you see that again, so your network, if you see that this kind of sub network where all the people are connected, they have some kind of common some way of commonalities. Okay, so this is also true for this, and this distributed representation is coming from that concept. Okay, this is not a very new thing. So earlier, actually the word themselves were used. Now everything is a vectors. The represent in terms of binary numbers, in terms of real numbers. So, okay. And there are a lot of advancement has happened in these areas. As you can see, probably many of you know that how to represent the word, how to represent the sentences. But the most important thing is this one, the explainability of AI, because all these things that you are doing, they are the particularly neural network based model, deep neural network based model, they are not very interpretable, they are not very explainable. Explainable means you don't know why something is happening, why not the other way. Okay. Now, if you want to interpret those, that okay, why this result is so good for this particular input, why it is failing, and if you want to very closely analyze, then that is not very straightforward like you have done in case of classical based machine learning. Because classical machine learning, you have the control on that systems because you have identified the features. But these days, these are very popular, and because of this reason, probably you know that these 3% were conferred with the Turing Award, and Turing Award is the most coveted award in computer science, because in computer science there is no Nobel Prize, right? So the prize, the Turing Award is equivalent to a Nobel Prize. And Benjio Hinton, so they are not very new researchers. They have been doing neural network for a long time. Deep learning at that point of time was not so successful. Now it is becoming successful because we have a lot of computational power. Computational power means also the GPU based computations. You can add many layers between the input and output. You can do a lot of computations. Okay, and so you are getting a lot of results. But earlier days, during 1980s, 1990s, at that point in time, the GPU based computation was not available. So if you are adding a lot of neural network layers between input and output and making it very deep network, then you will not get the results. Even these days also, large language model kind of situations needs huge computational power, right? Very computational expensive. So neural network at that point, most of the theories you see that in neural network, the very core theories, fundamental theories, they have come before 2000s. Okay, so most of them, and they have been doing it for a long time. Now they have become more successful, and because of that reason, particularly from 2013 onwards, and because of that reason, so they were given this award. Okay, so but you always remember this, that as I mentioned this analogy, that NLP and ML interaction is like this, because you can see it is a kind of marriage between two disciplines, and separating them will create problems. So you keep this aspect in mind. That means NLP, if you want to build, you need machine learning. You want to do machine learning, you need an NLP. And whenever you try to break this tie, then there will be a problem. Okay, so you have to see that they should be closely coupled together, and each of them needs the others for the upliftment of that particular area, upliftment of NLP technologies, or they say if you are coming up with a machine learning theories, how do you evaluate that how good is the theory? So this interaction you should keep in mind, and but the another cautionary, so if you are really doing NLP and you are not very biased to machine learning, okay, then because NLP, although it is dominated these days, most of the NLP research by machine learning, but Noam Chomsky, probably you have heard the name, that Noam Chomsky is the person who came up with the concept of grammar, right? Because in 1956, after Turing test was in 1950, where Alan Turing tried to know that how far the human intelligence, okay, is better than a computer's. Okay, he tested with posed a set of questions and then asked to a machine, and the same set of questions were asked to a human. Whatever answers they produced, those are sent to another human expert without telling him or her that which answers are coming from the machine, which answers are coming from the human. And if I give you these two set of answers, let's say ChatGPT is producing something and I am producing something, but I am not telling you that which is written by me, which is by ChatGPT. I ask you that can you tell me that which is written by ChatGPT, which is by a human. These days it is very difficult, but earlier in 1950s, those question answers produced by both were analyzed closely, and it was understood that one of the fundamental problems of a machine is that how to enable it for language understanding. So language understanding, one of the core problems. There are many other problems. For example, whether machine can derive a new hypothesis. As a human, you are creative. You have a lot of creative nature. You can discover a new mathematical hypothesis, new theory. Whether a computer can do it automatically. So those are the challenges. One of the fundamental challenges was if you can make the machine very intelligent, okay, that if you make it enable to understand the human language, then you can say that, okay, that at least one of the properties of human machine has achieved. Because if I ask you something, okay, always in a mathematical form, the communications will not be very engaging, right? So the human communication always happens in a natural language. So Chomsky came up with the concept of grammar to solve this problem, to solve the NLP problems. He is not a computer scientist, by the way. Noam Chomsky is actually a language person. He's a computational linguistics. Okay, So his purpose was to solve the problem of natural language processing and not the programming language. And he came up with the concept of grammar. He thought that okay, the language should be given a mathematical notations, and he came up with the notations. Now, programming language scientists borrow those ideas. So most of the programming language, if you see, that they started proliferating after 1956 historically. Why it has happened? Because of the grammar. Because every language has a grammar. Whether it is a C language, whether it is C++, whether it is a Java, Python, whatever language you see, every language has a compiler. So compiler means it follows a grammar. Now, if you need a grammar, so who is the person who invented this? So Noam Chomsky is the person. But please again remember, he is not a computer scientist. Okay, but the grammar concept everybody is using. His main purpose was to solve a problem of natural language understanding problem, that how the machine can be enabled to understand the human language. So what it says, that he says that okay, it's good that you have lot of data, you are doing lot of statistics, probability, a lot of parameters, hyperparameters you are learning, but language properties also plays an important role. So science of the language plays an important role. Until and unless you understand the science of the language, you cannot succeed after a certain point in time. Let's say now ChatGPT, GPT-4, after that what? So if I ask you these questions, so it's very, very difficult to answer, right? So what ChatGPT cannot do, what GPT-4 cannot do. If I ask you these questions, then you have to closely analyze the linguistic phenomena. Okay. So until and unless the language you understand very properly, the NLP research or the actual research after a certain level cannot be achieved. So you remember these, that if you are interested in NLP, so machine learning is okay, deep learning is okay, but if you do blindly with, let's say, these days many of us do blindly because of, if I ask you, let's say, build a sentiment analysis system, I give you the data, let's say in Hindi, for example, even you don't know the what sentiment analysis does, why it is positive, why it is negative, what are the triggers that it is making is positive, or what are the properties of the language. Even if you knowing that, without knowing that, you can build a system very easily. Now, because the data I made it available, I tell you that these are the 2-3 classes. You don't know the language, you don't know anything, but still you can build it. But you can do it up to a certain level. If you want to go beyond that, then you have to know the language very well. So this is what you have to remember always, that science is very important of the language. So theoretical insights you should have. Now, what actually we do? We actually do a lot of different research in different areas. So for example, one of the very important areas is our conversational AI, okay? And we are doing a lot of research in these, our group, in natural language understanding is the first step in any chatbot. Then you have dialogue management, then you have natural language generations. Also, we are doing a lot of activities in empathetic dialogue generation. That was also one of the properties of human intelligence. Two humans, when they are communicating, they probably understand each other's mood, right? For example, if you are very close friend and if you are doing very well, then probably I need to congratulate you. Okay. For example, now if you say that okay, you are not in a very good mood, so your friend should actually control the situations. So that means when two people converse with each others, and this conversation will continue for a long time only when you understand each other very well. Otherwise, the social communications also uh, does not remain for a long time. Any relationship you see, for any relationship between any two human, so that there should be a basis of common understanding. Okay. Otherwise, you have to understand each other very well. You have to know that when the others is happy, when others is in pain, and accordingly you have to act. Then only to relationship continue. Now we are replacing a human by a machine through is a kind of chatbot. Now, when a chatbot can be your friend, the chatbot can be your friend when chatbot understands all your feelings very well, your mood very well, then only. So this kind of very higher level, very, very complex problem. It is not a very easy problem. Okay. So can you make a bot that chat bot, conversational system that understands the human mood, humans' emotion, humans' sentiment, all these, and this actually is the empathetic dialogue generations. Then not so this is a very important line of research, and we have several publications on these empathetic dialogue generations. If you are interested, you can see from my Google Scholar or maybe from the DBLP. Then knowledge grounded dialogue generation is another important area where external knowledge helps. For example, if I ask you that why 2nd October is important in India, ask Alexa, for example, that okay, can you tell me why 2nd October is important in India? So now whether Alexa will be able to respond to your queries. 2nd October is important because it is the birth anniversary of Mahatma Gandhi in India. It may not be important in US, it may not be important in Japan. So that means location wise you see, and now how the bot will know that 2nd October is important in India because of Mahatma Gandhi. So these are the knowledge grounding that you have to know that the background knowledge, some Wikipedia, some newspaper, some blogs, extra historical evidences, and bot should extract those relevant information from those historical evidences and should tell you that okay, 2nd October probably is important in India because the father of the nation, so Mahatma Gandhi, was born on that particular day. So you see that this is a very difficult thing. It is not so easy. It sounds very easy, but this is not so easy thing. Okay, this knowledge grounded dialogue generations, and this is also very, very important problem that you can do. Personalization is another area that we work, that bot when interact with different person, they should understand their personality. Let's say you interact with a bot. If the bot understands that you are a movie loving person after 2 or 3 turns of conversation, then the bot should converse with you with the movie related topics. Then you will feel very good. But if you are a movie loving person and if I bot is talking to you mostly about sports related, then you will discontinue this. You will stop talking to the bot, and then you will just discontinue the communications. But on the other way, if the person is a sports loving person, now then the bot should understand that okay, this person is a sports loving person. How the bot will understand? When you start interacting with the bot at the very beginning, after preliminary some kind of interaction, the bot should be able to understand your personal profiles, your talking points that you are talking about, and it should infer from that you are a sports loving person. Then the bot should reorient the whole conversation towards the sports related activities, that it will give you many sports related news, if there is any cricket match, football match, when it will happen. So this kind of clue, the triggers they will give you, information they will give you. So again, you see that this is a very important problem. Even for personalized education is very important because different students have different priorities, different level of understanding. So when we talk about the personalized education, so whether they understand this very well, okay. So this is also very important, the personalization. These are all very interesting research areas. So if you want to do that, so you can do it, okay. So another area that is very important, that is very close to the real people, is the translation, the language translation from one language to the other language, okay, because this is extremely important problem in a multilingual country like India, okay. Like multilingual, Europe is also multilingual. Europe, different countries, they don't have any boundary between them. You can, if you have a kind of visa of Germany, Schengen visa, you can travel to Italy, you can travel to France, you can travel to Switzerland, any other countries you can travel. So it is not a barrier to travel to the other countries. Only the barrier is the language. French people speak in a different language, German people. Italy, they have a different language. Switzerland, they speak different language. So you see that different countries, Spain, different language. So different countries speak different languages. So now only this translation is a very effective mechanism or system that can bridge this gap. India is also like this. So North India, South India, East India, let's say if you are traveling from Calcutta to Bihar, Patna, then Patna you are going to Chennai, Chennai to some other, Assam, for example. All these states you see the different languages. So now, how can you make sure that this cultural barrier is not a barrier for the communication, is not a barrier for any other activity? So that is why this is very important. And we have been doing a lot of research in this. Actually, one is the judiciary domain, then education, e-commerce, etc. Sentiment analysis is also very important, and we have been doing it since 2014 onwards. There has been coarse grain, fine grain sentiment. Coarse grain means you give a document, you give the entire sentences, do the sentiment analysis. That may not be enough. So an aspect level we call, that is important. Multimodal, always a particular text is not enough. So you need the other sources of information, video, image, etc. Then we have also information extraction is a very large umbrella. Under that, question answering, event monitoring, misinformation or fake news detections, hate speech, novelty detection, whether information is novel or not. How novel is the information? That is very important. If I am repeating the same lecture again and again, so many of you will not be interested to know this because there is no new information into it. So that is how the people learns, right? We'll always learn with some novel things, right? So if something is new, then we are more interested. When we read a newspaper, why you are attracted to something? You are attracted in something because if that catches your eyes, and if you know that, okay, look, this I have not seen, that is the reason why another problem, it will also have some another problem. Rumor, for example, why the rumor spreads very faster, because rumor seems to be very new, because you have not heard something, you have heard which is very uncommon, unheard of, then you see that, okay, this has happened and you want to propagate that information in your network, right? So rumor, the fake news rumor, because of that reason also the novelty has a very important aspect. New information propagates very fast. Okay, so the lot of this kind of research we are doing with different socially relevant problems with different industries also. For example, Flipkart wanted to do this translation on e-commerce domain because during COVID, okay, so the e-commerce sectors, particularly e-shopping, etc., has been a norm of our life, right? So people do not want to visit maybe the shopping complexes or in a big market area. So people order it. So now, if this is only surrounded or concentrated in a metropolitan city or the urban cities, then it will not be very popular. So what about the semi-urban locations? What about the rural areas where the Amazon or the Flipkart can reach? They can only reach if the person sitting at the village in the rural area understand what to order, what are the properties of the particular product, okay, what kind of reviews people have written. When you these days you order something, we see that, okay, let's see the quality of the product, and we try to get the reviews about the product to get an idea what kind of features and everything. If it is written in English, then you will not be able to do it, right? Because the village people or the rural people who does not know the English, the common people, I'm saying that who does not know English, so they will not understand that what is written, what description is written about that particular product, what kind of features the product have, what reviews the other people have written about the product, because everything is in English. So this should be made available in the language so that the everybody understand it very easily. Then the people will use that particular system very often. So let's say if the Flipkart is providing all the catalogs, all the reviews in local languages, so as a common person, I understand it very easily. Then I will read it, I will get an idea. So the number of, let's say, the number of shoppers will increase very tremendously with the availability of this kind of resources in the local language. So that is the need of the society. So they wanted to do it. So novelty, for example, was important for the Elsevier is a publishing company. Novelty, that how a research is novel, okay, whether the research paper is talking something new, Now, how do you identify how AI machine learning will identify? So this kind of research we are doing, and conversational AI historically, if you see that it started with Elijah in 1960 at MIT, right? But now I'll just quickly give you that about. So mostly I have talked about these areas. So now let's see very quickly that what actually some more ideas. Okay, I'm not going to very technical details. It will take several hours. Okay, so rather I am trying to give you that in AI NLP machine learning where what kind of research our team is doing and why it is very interesting. So that is what I am trying to tell you. So now this Elijah was conceived long back, okay, and also I mentioned already that these are all the important features these days, that identifying that empathy of the speaker, making it personalization. So those were not there with this. It was merely a kind of uh, let's say today's chatbot, if you see, so it is not a kind of human to machine communications. So rather it is a human to machine conversation. Communication and conversation is different. Conversation means you have to deeply engaged into each others. Okay, that is what the conversation is. And communication means what? You are taking that as a media to let's say understand something. Okay, so these communications can be converted to a conversations. And if you say that, okay, until and unless you understand all these things, that human like aspects, you cannot make it very engaging. Okay, and this is important, this chatbot, because this is one statistics. You see that there is a tremendous growth, and almost 90% of the customer interactions in the next few years, every sectors in the society would like to make it automatic. Rather than a person sitting 24 by 7 hours, a bot will be there which will interact with you as a when you are speaking, when you are asking for a task to be performed. So that is the reality. Okay, so that you have to understand. Now, why this is empathy? Because, okay, so this is not coming anyway. Okay, so look at these conversation, because there was a graphical representation, but this is a PDF. It is not coming. So you see that this is the speaker. The speaker is saying that I finally got promoted today at work. Now, if the bot says, why would anyone promote you? Then you see that these interactions will not continue, because the person has been promoted and this bot is not acknowledging that. Let's say two friends are communicating. Now you are saying that, okay, look, that I got a good job in Google. And then your friend saying, you got a good, how can you get? So you're not so serious. So I'm surprised. So now if that expression happens, and this happens very, let's say, over a period of time, whenever you are doing something good, your friend is not acknowledging you, then that friendship over a period of time will not remain, because you understand now that, okay, this is better not to be associated with this partner for a long time. Okay. So this happens. Okay. So the bot is also like this. So if the bot says that why would anyone promote you, then this person will not feel good and it will not communicate for a long time. But if the bot says congrats, that is great, then you see now this person will be happy, because he or she understood that, yeah, so the bot has understood that the achievement of this person, and he or she has been congratulated, and so you will have a feeling that, okay, you got a congratulatory message, so you'll feel good, and this conversation will continue for a long time. Now, how this bot will understand? The question is how the bot will understand this person has been promoted and it is a very good news, and the person should be congratulated. As a human, we understand it. Now, replace me with a bot, and bot has to understand this, that you have been promoted, so it is a good news, so I should congratulate you. So this is an example of empathy conversational AI, that how the engagingness between the speaker and the bot should continue for a long time. Okay. Then we have also there. I hope you are getting the point what you want. Now it can happen that you are saying that, okay, look, that I did not get good marks in this particular subject. Okay. Now your friend should give you some kind of consolation and say, okay, do not worry, this is the mid-semester examination, you do well, but in end semesters you will get good grade. Okay, so if you the conversation happens, then you will feel good. So that means what? When you are happy, then also bot will have to understand and act accordingly. When you are not in happier mood, then also bot will have to understand both the situations, and it has to respond accordingly. This is what is the conversational AI. So another area is that multi-emotion. So when we talk, we actually speak with different kind of emotions. Okay, and emotion is a kind of you can say that, okay, the human aspects, right? For example, I am sad, I am angry, I am happy, I am surprised, I am disgusted. So there are different kinds of emotions are possible. Okay, so when we speak, so and when you converse with two people, you see that if you're conversing for some time, these emotions can vary. Maybe let's say I am very upset with you. So for example, so you have not, maybe if you are not submitting the assignment in time, you are not attending the lectures, then probably your teacher may not be very happy. But then at the beginning, then through the conversations, probably the teacher have understood, or that, yeah, so although you have missed some classes, but all the assignments you have submitted in time, then probably that level of let's say the unhappiness will decrease over a period of time. So that happens when you, even when two people are communicating, you see that if they are communicating for a long period of time, long period I'm saying that, let's say 2 minutes time you are conversing, 5 minutes time you are conversing, you see that emotion actually changes over the conversations. In a single utterance also, there can be multiple emotions involved. For example, these are the examples where it is amazing, I am thrilled you got promoted in consequence of this. So now, in this case, there are two kinds of emotion. One is the surprise and another one is the joy. Okay, so surprise is less, joy is more that the person has been promoted. So 0.3, 0.9 is the intensity we call that, how sad you were, or let's say how surprised you were, how much joy you were in the scale of 0 to 1. Now, if the bot, whether bot can understand that you are more joyous than surprised, okay, and accordingly you have to respond. So you see, it is not a very very straightforward matters, right? So when you are speaking, there can be multiple emotions involved, and those emotions will be expressed at the different level of intensity. Now, whether bot understand that, okay, that in this particular expression, joy is more and surprise is less, so I have to respond in a situation where joy kind of behavior will be more than the surprise. So that machine will have to understand both of your emotions, and when it generates a response, the response would be accordingly created. In the second case, for example, here you see that, okay, sadness and fear. Sadness is more than the fear. So now what kind of responses will be generated? So these are all very challenging problems in conversational AI, okay? And that if you look at your paper in AAAI 2021, we tried to define this problem, new problem, multi-emotion control dialogue generations, okay? And then also we have many other works on sentiment-oriented dialogue generation, knowledge-grounded dialogue generation. One of my students has completed PhD this year in this particular area. So you have to understand the intent, context, mood, etc. So of the speakers to make it more aware and relatable. Okay. Another important thing is this. So the politeness is also very important. Okay, politeness is a very important factor in our day-to-day communications. Okay. So in 2019, we tried to solve a problem that how we can make a bot very polite. And why politeness is important? Let's say customer care. You're talking to the customer care, you are facing a tremendous problem about a service, the mobile network, for example. Now you are in the hostel, for example, you are not getting the internet. If you are complaining, for example, and we understand there are some limitations. Now, if we don't appreciate or acknowledge that, okay, yeah, so we understand that you are facing trouble, we are trying to help you out in the best possible ways, but also we have some kind of limitations. You see that in various communications, if you are polite, if you are humble, okay, in different situations, that actually helps you. You are going to a restaurant, if the restaurant food is not good, and if you are complaining to a manager or the waiter says, okay, no, maybe your taste is bad, everybody says our restaurant is very good, then as a customer you will not feel very good. And after coming out of the restaurant, you will spread this information to your circle, to your friend, that okay, this restaurant avoid because they behave like this. So that will cause a damage to their business. So any service provider, any kind of business organizations would like to retain their customer base, and there the politeness, the courteousness play a very important role. Okay, for example, here as an example, you can see that I took it from a ongoing conversation. So the conversation was that a person was having a problem with the internet service, and the person has reached out to the customer care, and the customer care has responded, how can I help? This is the original response. Now after this response, the customer who has been facing a lot of trouble, the person may not be very happy, because let's say you are facing problem for a period of 3 days, and customer care, okay, tell me, generally we no other customer is complaining, only you are complaining, how can I help? Then as a sufferer, you will not feel very good. But now if the bot responds like this, that we are sorry to see you are having trouble, help has arrived, how can I help? So this part, this green part, you see, it is a notion of apology, that because you are facing a trouble, for that I am a service provider, I feel apologetic, and now I am trying to help you. So these apology notions will actually making the situation more comfortable. And even if I suffered a lot, I may not like to, let's say, discontinue this particular service for a long time. Okay, so that was very important, actually, very, very important. It has a lot of applications. Okay, for example, you see that there are some example here also. The person was facing problem, and then it is a Twitter conversation basically, and then the bot says, hi Christian, I'm happy to help, can you send us a screenshot? So you are doing a greeting because, hey Christiana, so assurance also you are giving, that happy to help, so I want to help you. Okay, then appreciation is thank you for your kind words, enjoy your show while flying. So this is a kind of appreciations. Okay, so now you see that this is not very easy thing, by the way. So if you are talking to your friend, because politeness will vary depending upon whom you are talking to. You are talking to your friend, you may not be very polite. By talking to your parents, you may have to be polite. You are talking to your teacher, you have to be polite. Then, so that means politeness varies depending upon the age, for example. Older people, you have to talk in a polite manner. Younger, whether bot will understand that I am talking to younger people, I may not be very polite. I am talking to older people, I have to be very polite. How the bot will know this? Forget about a human, we are replacing a human with a bot, and we want the bot to behave like this. Then, for example, gender is very important. Talking to a female, talking to a male, two different kinds of politeness. The same way you cannot talk. Okay. Now, it also depends on the geographical boundaries. Talking to a US people, talking to a Japanese people. So they have different kind of politeness. The way you are talking to the US people, you cannot talk to maybe the Japanese, because they have different kind of level of politeness. Okay, so you see that culture is very important. Language also plays important. Gender, age. So all these are the influencing factors for the politeness. And we have several publications. You can see these are all the conferences we have published on conversational AI. There are journals, etc. If you are interested, you can see. Now, sentiment also is another area that we are doing. And sentiment, we have been doing very deep research on sentiment analysis, coarse grain, fine grain analysis. Fine grain is more aspect level. There are different languages for different domains we are doing. Different kinds of solutions we are providing, either feature engineering based, deep learning based, combining these two, building a multitasking system that can do more than one task at the same time. And also it has a lot of applications. It has application in e-commerce. For example, which product to buy and what to buy. Security is very important, because people who are very talking very negative things about something, then government would like to know it, that why the people are so negative, what is the reason, right? So security also is another aspect where sentiment is important. Suicide ideations also we have done. If the person has committed suicide, So now what are the mental states so the person has gone through? So this kind of work on our student has done, Soumitra has done on suicide ideation. Mental health, we are doing a lot of activities these days. Mental health also has a lot of relations with sentiment and emotion. And there are many problems, okay, sarcasm, humor, all other related problems to the sentiment and emotion analysis. Sarcasm is very difficult, right, to handle. For example, if you say that, okay, I woke up in the early in the morning at 3 a.m. with the beautiful bite of a mosquito. If you say like this, so I woke up early in the morning at 3 a.m. with a beautiful bite of a mosquito. Now, beautiful is a good word. So you say that, okay, if you only supply this written text, then your model will say, okay, beautiful is a good word, so it is positive. But actually, you are not positive. Now, how the model will know? When you said this, if your visual expression was made available, okay, your image, your facial expression, then although you are writing something very positive, but actually you are negative. Now, this is a kind of sarcasm. So, understanding sarcasm is very difficult. It is not a very straightforward thing. Not only the positive and negative, but how positive you are, how negative you are is also important. If you say movie was okay, and then you say movie was good, and then you say that, okay, movie was awesome. All are positive. Okay is not bad. Good is also okay, positive. Awesome is also positive. All are positive. Now, if the person, if you know movie was awesome, then I will be more tempted to watch that movie. But if you say that, okay, movie is okay, then the listener may not be very tempted, right? So you see that when you do the sentiment, the intensity of the sentiment will also influence your decision making process. Okay, this is also very important. And why this aspect level? One of our student earlier, Saad, now he is in Triple IT Delhi. Actually, probably maybe you have heard the name Saad Akhtar. So he actually started working on this aspect-based sentiment analysis. Now he's a faculty at Triple IT Delhi. Okay, and we tried to do this aspect level sentiment analysis. That why aspect is important. Okay, because you see that this is a review of a laptop. Now, if you do a sentence level sentiment analysis, supply the sentiment, each of them, okay, and then you do the average of these sentiment values, okay, then you will see that overall the sentiment will be in the, maybe the rating will be in the range of 1 to, let's say, 5 range, it may be 3 or maybe 3.5. So now as a customer, if I look at this rating and then whether I'll be very tempted to buy this product, I may not be tempted because it is just above the average. But now let's say I'm a customer who was actually wanted to buy something, a laptop that is not very expensive, and also it has a good zoom, then you see that the zoom is excellent. Okay, so that means as a customer, I should prefer to buy that product because zoom was good. Great value for price. So price wise, the product is good. So if my requirement is a zoom features, I'm not interested about battery, that how long the battery remains, okay, or that I'm not concerned. I'm concerned about, let's say I need a laptop which has a good zoom, and also at the same time I do not want to pay much. Then this product will be good for me. From this side, you are not getting that idea. But if you have this idea, the price wise 4.5 in the scale of 5, zoom wise is also good, picture quality is also good. The customers who are interested in these features, they will buy this. Customer who are interested in battery life and display, they will not buy because 1.5 on very low. So you see that customers' requirement, users' requirement are not same. Their requirement varies from one user to the other users. Now, if you provide these information, so that actually helps you to give you the more accurate information. So this is what is the fine-grained sentiment analysis or the aspect level sentiment analysis. Okay, we have done different kinds of work in this. So not only for English, rather Hindi also we have created resources, multilingual one. lot of things we have done in aspect-based sentiment analysis. Now, another thing that I was giving an example that multitasking is as a human brain, for example, we always do multiple tasks at the same time, either explicitly or implicitly. Now, sitting in this classroom, maybe many of you are thinking that when this lecture will get over, how long we have to listen to this, or maybe what you will go, how do you travel after 29, what will be your new year plan. Although you are hearing my lectures or maybe you are seeing this, but your brain also is doing several other tasks. So that is the reason why human brain inherently is a multitasking system. It is a distributed system. Okay, it can do a lot of parallel activities at the same time. Now, if you want to replicate this human brain through AI-based systems, then AI should also be able to do multiple tasking at the same time. So this is the what we call as a very strong AI. Okay, the concept of strong AI, or you can say that okay, very powerful AI. Okay, so a strong AI is possible where the machine can also do the same way as a human brain does multiple tasking. So now, when can you do multiple tasking? You have to identify that which tasks can be performed together. Okay, and then you have to build the systems. Okay, in this case also we have done that sentiment and emotion. These are very correlated. So if you know emotion is anger, fear, disgust, and sad, the sentiment will be negative because anger cannot be positive. Fear cannot be positive. Disgust cannot be positive. Sad is not a positive. So sentiment and emotion, they are very closely related to each other. Sentiment remains for a long time. Let's say if I form a positive sentiment about you, positive opinion about you, then it will last for some long time. But the emotion has a short span. Suddenly I can become angry, and then probably in the same conversation, I can go down. So emotion, the lifespan of an emotional state is not very long, but the sentiment remains for a longer period of time. So these two tasks can be combined together, and also it has several advantages. You see these examples. So as I was giving that mosquito bite, here is another example. Thanks for putting me on hold. I have all the time in the world. So I have taken this during a conversation. A conversation was going on between two persons, and the person was very unhappy because he has to wait for a long time. And the person said this during that time. Okay, thanks for putting me on hold. I have all the time in the world. So that means what? Thanks word has been used here, right? But the situation, the context where the person has spoken was not actually a Thanksgiving kind of situation. The person was extremely annoyed because he has to wait for a long time, and he said this. Now, if only this written text I give to a machine and ask that, okay, can you tell me that what is the sentiment out of this? Your machine will tell it is a positive sentiment. But actually the context where it is spoken is actually was negative. How do you know that? You can only know when the person has spoken this, if the gesture is available, eye movement of the person is available. You are writing positive terms, but eye movement will be different if you are actually negative. Facial expressions. Okay, if you have spoken, there will be variation in the pitch. Okay, so this will make you understood that this is actually a negative and not positive. And only text is not enough. That means what you need? You need the visual expressions. You need the audio expression, audio speech that when you have spoken. So this is the multimodality. That means multimodal information is actually helping you to make a better decisions. The second one is also a kind of example. I am fine. The person has spoken. Fine is a good word. So machine says, okay, it is actually positive. It will say like this. But here the emotion is actually shared because the person has some kind of mishap that his friend was trying to console him. And the person says, okay, do not worry, I am fine now. So although I have said I am fine, but I have said it not happily. I have said it from the sadness that has happened with me. Now how the machine will understand from this text only? You need the whole context. If you make this facial expression of the person available, then only. So this shows that multimodal information, multimodal NLP multimodal AI when we talk about. So it is not only one form of communication, other communication is happening from multiple ways. Okay. So this you should keep in your mind. Okay. The another important thing that we have done, and one of our student have done his PhD already, and another student is also doing PhD in this related topic. That the peer review systems is very complex. Peer review, maybe if you are have published some papers, probably you have some ideas, or if you are willing to publish some papers, want to go for let's say any research, okay, take up research, MS, PhD, etc. You will get an idea that what is the time now? Oh, it is right time. Huh? 25. Okay. So okay, I'll take another 10 minutes and then I'll maybe I'll close. Okay. Huh? Is okay. So then what we try to do that how AI, machine learning and NLP can actually help in these situations, okay, in automated peer review systems, okay, because peer review system unfortunately is not very unbiased, okay. Very good conferences, let's say AAAI is the best conference in AI. Okay, now it gets 10,000 papers. Now 10,000, every paper should be reviewed by 3 reviewers. So you need 30,000 reviewers. 30,000 reviewers should be experienced also. They should not be immature. How to get these 30,000 reviewers for a conference? And in a year, you see that there will be multiple conferences. Okay, AAAI, ISCAI, ACL, EMNLP, this guy NEEPS, for example, ICML, they get huge number of papers submitted there. So now the situation, the program chairs who are managing this, area chairs who are managing this, or a journal editors, the associate editors who are managing this, are very difficult. Let's say one reviewer is saying, this is a fantastic idea, very novel idea, very good. Now another reviewer has said, okay, no, this idea is very bad, so it is not publishable. And then one reviewer has given 5 out of 5, another reviewer has given 2 out of 5, another has given 2.5 out of 5. Now as a senior person, the area chair, so let's say the senior person, they look at the reviews of the independent reviews that 3 reviewers have written. And then I have to decide that who is correct, that whether 5 is correct or 1.5 or 2.5. I have to make a summary out of that. And then I have to give a final decision. Now, if there are 10,000 submissions and 30,000 review written, so this is a quite unmanageable task. Okay. So how a good decisions will be taken? So this is a problem in the scientific community. So Elsevier, so they actually wanted to set up a center in our institute. So it was Elsevier Center of Excellence. So this is what it follows. Any paper publishing cycle, particularly in a journal. Elsevier is a journal, not a conference. Elsevier published journals only. They have many journals. Okay. So generally, this is the cycle we follow. We author submit the paper. If it is out of scope, let's say I am submitting a paper in AI journal related, but there is no AI component, then it becomes out of scope. That will not be accepted. So immediately it will be rejected to the authors. Then let's say it is within the scope, then it is forwarded. Then there will be a checking that whether you have copy pasted it from other sources. So these are extrinsic plagiarism, that the word overlap they will make. Now word overlap identification is easier, but what is the intrinsic plagiarism? If you have changed the structure, if you have changed the meaning, you have written, paraphrased the sentences. Paraphrase means what? You have written the same thing, meaning are same, but the wordings are different. Okay. So now how the machine will understand it? That same concept you are publishing with a different flavors, okay, different ideas. This is a serious problem in the scientific community. Okay. So even if this passes, then there are some plagiarism, let's say 20% are acceptable. Okay. Then it is again sent back to the author that, okay, look, that your paper has this problem, so please correct it. Okay. Otherwise, it is forwarded to the next phase, and let's say if you can do all these things automatically by the AI systems without any human intervention, then these efforts are minimized. Okay, we will not engage any human in this particular portion. Now, editor is a person. Editor comes. Now, editor has to see that, okay, what this previous steps has said. Is there any plagiarism? How much is the plagiarism? Now, editor has also a lot of tasks. Okay, he has to see the paper, assign to the associate editors, etc. Has to understand what are the good points in the paper, selling points in the paper, whether the paper is presenting a novel idea. That is not the novelty I talked about novelty. It was the main concept, how novelty we try to bring into the pictures. Whether the paper is novel, whether the results that you have reported, whether the results are state of the art, that you have made the comparisons with the others, whether your codes, resources are made available. So there are different aspects on which a paper is evaluated. Now, if AI can help in these aspects, let's say the AI can tell you about how novel is the paper, some ideas. I'm not saying that you are deciding through AI. I'm saying that AI is helping you. Okay, you cannot replace a doctor. Basically, AI can help the doctor. Okay, you cannot replace a Supreme Court judge or the High Court judge. They can help. AI can help them. So it is a kind of assistive system. Okay, so then how novel it is, whether it has been significant enough, whether it has compared with the state of the art. If all these informations are made available to the editor through an AI system, the editor will get an idea about the paper. And that information, it can propagate to the reviewers that, okay, look, that this paper has problem. This paper has not made the data available. This paper has not made the resources available. This paper is an incremental work, is not very exciting idea. This paper, so a lot of things, these ideas, if AI can give you, then already I get let's say 10,000 submissions if the person is managing. And if for each of these 10,000 submissions, if the AI system is giving this kind of ideas, this kind of information about the paper, then your tasks will be reduced significantly. Because now you have some ideas about each of these papers. And then accordingly you can decide. So this is a very interesting and very realistic way of doing research, and we have been doing it for a long time. And we have this computational linguistics is the best journal in particularly only for NLP. The CL journal has a reputation in the sense that it is the best journal. And I think from India there are only 3 papers so far historically. Until now, in 2023, only one from IIT Kharagpur, one from IBM Research, and the third one from our place. Okay, only 3 papers from India have been published so far in computational linguistics. So it is a very comprehensive journal, and IIT Kharagpur Pawan Goel was there. Probably you have heard the name. So he did a comprehensive different tools for Sanskrit language processing, and IBM Research, they did some kind of the natural language generations kind of different things, and ours was the novelty, that how information is novel. So that was the main comprehensive idea. So you can see this very detailed analysis we have done. The natural language engineering is another good journal. ACL, probably you know, the top tier conferences. JCDL is a conference in digital library for this kind of work. This is a very good conference for digital library. So we have done this. If you have any, if you are interested, you can get those kind of information. These are publicly available. Translation, I told you that why it is important, and because it is connected to the real world. That cultural gap, language gap, how can you break? You have to build a system that will translate your, let's say, even our delegates go to Russia, Russian delegates come here or any other country, there is an interpreter in between, right? Because they are speaking in their own language and there is an interpreter. Now this translation is a kind of interpreter. And it is not a new problem. It actually was a necessity starting from Second World War. When the Second World War started, so Russia was in one side and the Western world was in another side. So and Russian was not very
let's say, they don't advertise many things. They don't publish many important scientific inventions. Okay. So the Western world wanted to know that what is the strength of Russia. So they wanted to translate whatever information is available in Russian language. So they wanted to translate everything to be made Russian books, etc., whatever is available, the papers, etc., to be made available in English. To understand the Russian strength, that was the necessity of the society at that point in time for the Western world. Second World War, Russia was on the one side, Western was on the other side. So it becomes a kind of cryptographic problem. So you are encrypting something, let's say Russian language, I don't know. So Russia seems to be a kind of encrypted message to me. Now, how can you decrypt it? So you have to find a mechanism to decrypt the language, Russian language. That means here the decryption is happening to the translation. You are building a system where Russian language will be an input and output will be a English language or the language that I understand. Okay. So that was the main purpose, and we have been doing a lot of things. Let's say low resource machine translations, unsupervised multilingual neural machine translation, deep learning based. Because earlier Google even was using the statistical machine translation. Okay, the phrase based machine translation we call. So now everything is neural network oriented. They are migrating gradually to the neural machine translation. Everything is deep learning based. Okay, so then interactive NMT, that how can you improve the NMT systems through neural machine translation by taking feedback from the actual users. And we had focused on these three domains: judiciary, education, e-commerce, as I mentioned with Flipkart. Judiciary was from the is a ministry project because our government wanted to see that how AI can help in the judiciary systems, the court. And our judiciary system has a 4-tier systems. Okay, so we have the local level court, in the subdivisional court we say. Then we have a district level court. Then we have high court. Then we have Supreme Court. So these are the different steps that everybody has to follow if you are in litigations with some party. So now, when the decisions are taken in the Supreme Court, the lawyers in the Supreme Court, they argue only in English. They don't speak in the local language. But let's say I am from Bengal. All the proceedings happen in the subdivisional court, district court are in Bengali only. In Bihar, everything is in Hindi. In Tamil Nadu, everything will be Tamil. So in India, in every state, in the lower level, all the decisions, all the proceedings happen in the local language. Now, when it is heard in the high level, Supreme Court, let's say, now if the case generally runs for a long time, if a case has run for 5 years, 6 years, 10 years, you can assume how many documents can be generated. Let's say 10,000 page documents have been generated. Many eyewitness, lot of FIR copies, lot of petitions has happened, and a huge amount of document. When it comes to the upper level court, you cannot, now who will translate these Bangla, let's say, or Hindi to English? Who does this? There was a requirement. So the court has professional translators. Professional translator means they're the human expert. They will have to read line by line and they will have to translate it into English. Now, if it's a 10,000 page document, you have to read line by line and translate the document, you can understand that how long it will take. How AI can help here, whether an automated translation system can reduce this effort by 80%, by 85%, that you present all the documents, translate it in one shot, employ the human, and ask the human to those contents, take those kind of contents, that whether it is correct. In the case related documents, I'm not saying that all the contents, all the sentences you have to read. What is important, when the Supreme Court lawyer or the judges would like to know that when the FIR was made, who were the parties involved, what are the courts, in which court it was heard, who were the lawyers, who were the parties involved, how many eyewitnesses were called for the interrogations, what was their statement. There are certain information that you cannot mistranslate. I am not saying the translation is an NP complete problem. You cannot do accurate translation always. It's a very hard problem. Translation is one of the hardest problem in natural language processing. Okay, because the language very much varies from one human to the other human, and human are very creative. So conveying meaning in the target language is very difficult. But the important informations, if you can preserve, then the effort can be reduced 80% or 85%. That was the purpose of this project. Supreme Court wanted to build it. So then the government wanted to that, okay, all the information, whether AI-based system can do the translation, and the human expert will just check the important information, whether the important informations are preserved or not. That will be the only task. So reduce the human effort by the AI system by 80%. It also needs the other way around. For example, Supreme Court, all the decisions are taken in English. Now, I am a litigant. Let's say I am from a village. Now, I want to know that my lawyer says that, okay, your appeal was not considered. You employ a lawyer, a lot of money, okay? And then you want to know that why my appeal was not considered. So, I want to know the proceedings that has happened in Supreme Court. What was their observations? Now I don't know. I want to make it available in the language that I understand very easily. So all the decisions in the Supreme Court should also be made available into the local languages. So that was the reason why this judiciary was important for translation system. Education is important because nowadays you see that all the educational content, if they are made available in the local languages, that actually helps the students a lot. Because many of the students, everybody is not coming from the English medium schools, right? So they are coming from different backgrounds. Now suddenly everything is in English. Many students do not cope up easily. So now if all the NPTEL lectures, everything, let's say all the educational books, contents, engineering books, medical books, if they are made available in the 22 official languages in India, that will be a very important task, right? Other countries are doing that, Japan, Europe, you see that they are available in their own languages, right? So then we are doing a lot of several projects. For example, we have done, as I mentioned, this publishers company was doing that how AI can help, machine learning can help in peer review systems. Then Accenture, right now we are working that how can you build a good chatbot that can negotiate with you. You are doing a deal. Let's say you want to purchase something, a flat you want to purchase. So there is a broker in between. So you are negotiating with those people. You are buying something, that how the bot will influence you to that, so that at the end you buy. Let's say you have made your mind that you want a blue color, let's say cell phone, for example. You have gone to a shopping place and then blue color phone you don't get. Then as a customer, I feel okay. I thought I will buy blue, but now I don't get it. Now, how the agent should do? The agent should convince you that, okay, look, the blue is good, very good, but also we have alternative good colors. See, the green is also looking very good. So it will look very good. Black is also very good to your personality. You see that agent does all these kind of things, right? As a human. Now you see that you replace the human by a machine. Whether the chatbot can do like this and can convince you, can persuade with you, can convince you, can influence you to buy that. So that is a very important thing. It is not an easy thing. Okay, charity donations if you do. So charity people don't want to do easily. Now when people come, you ask a lot of questions. Okay, I don't know what you will do with this money charity. I am not getting any information. They will ask you, sir, can you? And then the person who is convincing you, he or she has to be very knowledgeable. That he has to convince you that why you need to do a charity, how it will help, let's say, underprivileged children, or the persons who are not getting proper medications. Okay, how the society at large will be benefited. So you see that there are various spheres where these persuasions, negotiations are playing a very important role. So that actually we are doing this. The judiciary translation we did with other institutions, IIT Bombay, Delhi, IIIT Hyderabad, IIIT. Lot of institutions were involved. IIT Patna was the coordinating institute there. Then there was another thing that we had did earlier with a platform for cross-lingual and multilingual, even monitoring in Indian languages with IIT Kharagpur. Then DICT is the Dhirubhai Ambani, UKBC, IIT Bombay. Right now we are doing this with Wipro. They wanted to do develop the systems that can help in healthcare systems. Its name is Parcuro. So Parcuro is a holistic solution for text mining. Okay, in clinical domain, medical domain. Okay. Then another project that we are doing with, this was mainly we are doing with AISC USA, and it is sponsored by Wipro. This was is for hate, hyperpartition, and hyperpluralism meditation, and we are doing it with UT Austin, IIIT Delhi. Okay, this project is mainly the hate speech detection, fake news detection. Right now, another project that we are doing with Vidyapati. Vidyapati is the, I don't know how many of you have heard the name, but he's the person, he's a kind of linguist, like Noam Chomsky I told you. So he was a poet, and from this region, Maithili region, okay? And he's very well known for the language, for the grammar, etc. So we are building a systems to translate the documents, agricultural document, educational document, administrative, let's say government websites, etc., from English to Hindi, and then Hindi to Bangla, Konkani, Maithili, Marathi, etc. And there are other institutions involved: IIT Bombay, JNU, SIDA Pune, SIDA Kolkata, Jadavpur University, ISI Kolkata. And our goal is to, for IIT Patna, we are mainly focusing on Maithili, that how can you build a system for English to Maithili and Hindi to Maithili, and also Hindi to Bengali and English to Bengali. That is our responsibility. Another project that we are doing with IIIT Hyderabad is the main here. This name is Vasini. So Indian government has, Prime Minister has 5 different top agendas, and one of the agenda is AI for all. Okay, then the cyber security is the second one, and the top priority is the NLTM missions. The NLTM is the Natural Language Translation Mission. The idea is that translate everything, all the documents you make available in the Indian languages. Okay, so Bhasini is the name of that particular platform that is focusing mainly on that. We also have a Ministry of Home Affairs related project where we are actually focusing on creating a kind of, where I particularly work, that how sentiment and emotion helps in understanding the crime victims' mental states, and also how can you build a chatbot that actually can help the women and the girl child who have been abused in the internet. They may not tell to their parents, okay? They may not reveal that what has happened to them. They many times, because of the societal reasons, because of they are, let's say, if they are from the rural areas, even from the urban areas also. So they hesitate to tell what has happened. If there is a workplace harassment, for example, many people don't speak. Many girls, many school girls don't speak up. Okay, many college girls even don't speak up. Many women don't speak up. So can we build a kind of bot that actually can motivate them, okay, that to come out of the mental trauma, and also can help them for that why they should take up some legal actions, what kind of legal action they should take up. So we have in various publications, we have in recent time, if you see my publication, we are doing this, that chatbot for mental health counseling and legal counseling, particularly for the women and the girl child. Okay, and we had in AAAI, we had AAAI, ACL, EMNLP. In the last 2 years, we have at least 7 or 8 publications in these areas. So if you are interested, you can see this, and it has a lot of real applications. Okay. So this was the machine translation, as I mentioned, and this demo is available here. You can try. And why it was needed? Because you know that justice delayed is justice denied. So the significant delay was happening because of this huge amount of documents that are produced every day at different layers of the court in our very big country. So how to manage with this? The pendency of the cases is a big problem in India. Whether AI can help, we are not saying that AI should give a judgment, but AI should facilitate this process. So that is what was the purpose. Okay. Now, MT in e-commerce, as I mentioned, that product reviews translation from one to other language. You can see a demo. Another project that we did with its name is Sebak, that how can you build a intelligent AI chatbot, and this was able to converse in different languages, let's say English, Hindi. If that website is not working, the demo, you let me know, because when we made it publicly available, so there are a lot of people commercialization, they were getting this thing translated without proper citation. Sometimes we make it closed, okay, so that it cannot be misused by some people, okay. That is the reason. So then this chatbot was mainly the multilingual chatbot for English, Hindi, Bangla, and code mix. Code mix, you know, right? So mixing up language, like English, for example, Tenglish, for example, all these languages. And we did it for 3 domains. Railways, we did it very well because 3 of the domains are very big. But railway, we worked extensively. We also built on healthcare and then judiciary. And this was integrated in WhatsApp, Facebook, and also web interfacing. This was a project that started in 2018, and we had finished it already in last year, to 2020 March. And here also Wipro was one of our industry partners. Okay, there are other things are going on. So if you can look at our research, you can get some ideas what is happening. Now there are many things I cannot talk about in details, but if you have any questions from anything, you can ask me. Okay, so that you have, so I'll share with this, so you'll get more ideas that what we are doing, very extensive. Okay, so I see that with paper informations, but I tried to give you an overview that what we are doing. Now a lot of technicalities are there, so missing translation, etc. So I'll share with you so that you get an ideas. Okay. So, but if you have any questions in any topic, you can ask me now.
So that use standard techniques to fuse multiple modalities.
Yeah, but the fusion of the modalities is an important task. Yeah.
So like what could be few standard methods to look at?
Standard methods means what? So you see that there are let's say block fusion is a very useful method. So you can use it. BLO, CK block. Okay. There are other things. For example, in some of our paper we have done in SEL 2020 paper, we have done that if there is a video or let's say snippets, okay, you have to create the different video frames. Now text also is spoken. Now audio is also there. Now it is important when you are fusing them together. So there can be noise also, right? So the one aspect you have to see that how to remove the noise. Noise removal is important. Now you say that noise is not there. Everything was recorded in a studio, very high quality data. Everything was high quality. Now you are giving this, let's say, you have to understand that when you are reading a text, that which particular text corresponds to which particular video frame. That alignment, that video frame correspond to text alignment, text to the audio particular frame. This alignment is a bigger problem when you are fusing. So that alignment, if you can do at the very final level, then your integrations will be successful. So we had done a sarcasm detection. We had a paper in SEL 2020. So that how sentiment and emotion helps in sarcasm detection in a multimodal environment. There you see that we have segmented the whole things into smaller segment, and then we have tried to align it at the very independent segment level. Okay, that was 20, but these days there are a lot of other techniques that also come. So block fusion, so we know that it is helping. It does well in fusing different informations. But yeah, so first thing is that you have to understand that which text correspond to which video part and what audio part. That alignment, if you cannot do properly, then if you combine them everything together, fusing them everything together, then it will not be very useful at the end. You will not get good values at the end. So you want what? After fusion, the better predictions. The decision should be better compared to individual modality. That should happen. Okay. So any other questions if you have? Yeah.
How the data sets are generated from multi-languages and machine translation?
Yeah. So but machine translation, data creation is a problem. So when we started at that time, for our judiciary case, there are at first you need some amount of data. If you don't have data, then unsupervised NMT system you can build where you have only monolingual data. Let's say English to Hindi translation system you want to build. So what kind of training set we need? We need a training set where there will be English sentences, and for each of the English sentences there will be equivalent Hindi sentences also. That means this English sentence corresponds to this Hindi sentence. This kind of alignment is needed. It is known as the sentence level alignment. but that is not available for many languages. Now if you have, let's say, but if you have, it may have the monolingual information. Monolingual means I'm saying one is the bilingual alignment, you don't have, but you have the monolingual data. Let's say you have the whole English Wikipedia is available with you. You have the whole Hindi Wikipedia is also available to you. It is available, but you don't know that which English Wikipedia sentence correspond to which Hindi Wikipedia sentence. That you don't know. So the monolingual data, if you have separately, so you can use it by and build an unsupervised neural machine translation system. Look at your paper that we had published in 2019 for unsupervised multilingual NMT. We assume there is no parallel corpus available, parallel data available. Okay. The other way, but its performance will be limited. Unsupervision, no teaching, nothing, obviously performance cannot increase. So we can get some amount of data created through this process. You need some help of the human translators also, because it cannot be completely automatic. Okay? Like you have to, human intervention is also needed for checking, for verification. Okay? And data augmentation techniques are there. Let's say there is a concept of back translations. Okay, data augmentation, that means what? You have to build some kind of systems, some small amount of data you have, and then use it to train your model, translate lot of documents, and then again you translate. Let's say if I translate from English to Hindi, okay, and then Hindi to English again. So what do you want? The source English sentence should be same as the target English sentence, because first translation system does the translation from English to Hindi. Second system is doing Hindi to English. But as the English is the source, then everything should be similar, right? So what I'm saying is that this kind of reason. So you have to ensure that this happens very smoothly. So let's say it was English to Hindi, for example, and this Hindi to English. Now this English should be same, right? Now this does not happen. Even in Google Translator, you can say translate for, give a long sentence, English sentence, translate to Hindi. Whatever you get in Hindi, again you translate from Hindi to English system in the reverse way, and then see whether same sentence you are getting or not. So now if you are making these, that we cannot get exactly the same output here, the same, this English and this English may not be same. So you have to do something so that they should be exactly similar to each other. They come very, you can consider a kind of loss is happening, a loss function, a kind of system you have to design so that when you are translating English to Hindi and then Hindi to English, this English and this origin English should be very close to each other. So this way you can gradually refine your unsupervised neural machine translation. You call it as a back translation. Nowadays, large language model also you can try, that you can use it for generating some synthetic data. They are the noisy data. They are not the pure data. From synthetic data, you can create a lot of pure data. Okay. So noisy data for a Samanantar, so AI for Bharat, probably if you know that IIT Madras has a startup, AI for Bharat. So they created a lot of data on for translation into different languages. This is known as a Samanantar corpus, parallel corpus. But they are all curated data. They are not human. Human intervention was very little. There are a lot of noisy data they have collected by independently monolingual data. They have stitched together by doing automatic processing, sentence similarity, etc. So these are data augmentation is a technique. Now, denoising autoencoder, if you have heard. So by introducing the noise in the sentences. That means what? Noise means what? Arbitrarily change the words in a sentence and generate different variations to that. So noising, denoising, autoencoder, so synthetic data creation, data augmentation, these are all the different ways to handle this. But you need some pure data. It completely cannot ignore the human. Human should create some pure data, build the model, use it for creating a lot of synthetic data, and then see whether it is helping. So without any parallel data, it is difficult to build a system, good systems. Okay. Some amount of parallel data is needed for this. Okay, any other questions? Okay, so thank you once again. Maybe all the best for your all your futures.